going to try to do a video of this problem. Several people emailed about this one from the homework. This is a washer volume problem. So your numbers might be slightly different. The one I'm looking at had the region defined by y equals 1.4 minus 1.4 times the absolute value of x minus 11 and y equals 0, or the x-axis. So we need to find that region. And then the solid formed by rotating that about the y-axis, we want to find the volume of it. So first thing I'm going to do is try to understand the picture. This seemed to be causing a lot of problems for people. So we've got to understand what this absolute value function looks like. Without doing too much work in thinking about transformations, I do know it's going to be an upside down version of that typical absolute value shape, the V. So it's going to be upside down, and it's going to be raised up by 1.4, right? That's a transformation, a vertical shift. So now I can already kind of picture what's going to happen. It's going to be some kind of V shape, an upside down V above the y-axis, its vertex above the y-axis, or x-axis, excuse me. And then the line y equals 0 will come under that vertex, so we'll have some kind of little triangle above the x-axis, and then we rotate this shape. So it'll be some kind of like triangular donut. So let's do a little more detail. So I'm going to start by finding out where this absolute value function hits the x-axis, right? Find out where it equals 0. We can add this to the other side and divide by 1.4. What we end up with is that the absolute value of x minus 11 has to equal 1 for this to equal 0, which leads us to two conditions. Either x minus 11 equals 1, which means that x equals 12, or x minus 11 equals negative 1, and then x would equal 10, right? This is what the absolute value does. If the inside, for absolute value of x minus 11 to be equal to 1, then this part inside is either equal to 1 and then absolute value does nothing, or it's equal to negative 1 and the absolute value removes that negative. So that tells me the two places where this hits the x-axis. So let's draw that in. So I'll sketch some axes. So right now, I'll just put it out here. Here's 10, here's 12. So this is 10, 0, 12, 0. And I know that the vertex of this absolute value function will be 1.4 above the y-axis. And I also know it will happen at x equals 11, right? This minus 11 represents a shift to the right of the absolute value function. Normally its vertex is at 0. We've shifted to the right by 11. It's going to be right in between these two intersection points, these two roots. So I'll put it right here. This is 11 and what did I say? Oh yeah, 1.4, right? That's how far up it's been raised. And so I'm not going to draw in the rest of the functions, but you can imagine both of these lines continuing. This one going off to the right, this line continuing off to the left is what this absolute value function looks like. You know what? I'll just sketch it in a little bit just to give you the idea, right? After the transformations, that's the picture. So now adding in the line y equals 0, which is the x-axis, this is the region. This triangle sitting on top of the x-axis is the region we're interested in. Then we're going to rotate it around the y-axis. So we're going to have this donut that's flat on the bottom and very wide that comes up to a point on the top. So I will just sketch in the other side of it, something like this. And when we rotate it, right, we would have a shape something like this, right? This is just the back half, if you can see the perspective I'm trying to draw. Okay, so if we're going to use the washer method on this, which is what the problem asks us to do, I'm imagining, right, if I imagine cutting this up, so I'm not going to draw them all in, but if I had a stack these little slabs, then when you rotate those around, they would each be a washer. Those are our approximations. I won't try to draw this too much, if you can imagine this thing though. If I pulled this out, right, this is one of our washers. All right. And we know that the volume of a washer, we've talked about this in class, we're going to have pi times the big radius squared minus pi times the little radius squared times the thickness or the height, right? This part in the parentheses gives us the area. It's just the big circle minus the little circle, the area of the big circle minus the little circle, and then the height gives us the volume, okay? So we need to find out how to define all these things in terms of the information given, right? So from our picture, since we're slicing it horizontally, the height is this little distance in here, which we usually signify as delta y, right? We're going in terms of y. So in this formula, h is going to be equal to delta y. So we need now the big and the little radius, right? In this picture, the little radius is from here to here, and the big radius is from there out to the outer edge, right? Well, now I want to come back to my graph and think, where did these things come from, right? The center is starting at the y-axis. The distance, let's talk about the inner radius, is how far until we hit this left side of that triangle. That's our little radius, okay? Well, how far until we hit this is defined by this absolute value function. That's when we know to stop, when we get there. It's this x value, right? The outer radius I won't draw in, but is the same idea, but going all the way out to the outer function, that x value. However, we don't want x values. We already know we're doing delta y. So we want everything in terms of y. So we've got a little bit of work to do to figure this out. So we need to start with this absolute value function. Y equals 1.4 minus 1.4 absolute value of x minus 11. Remember, we need to think of absolute value as a multi-part function. On the one hand, if x is bigger than 11, or equal to 11, then what's in here is either 0 or positive, so absolute value does nothing. On the other hand, if what's in here is less than 11, then this will be negative and absolute value will be multiplied by negative. So if x is less than 11, this x minus 11 will be negative and absolute value will multiply it by a negative. I'm going to put that multiplication of a negative into that minus there and make it a plus. I think that's the simplest way to write it. You could leave that as a negative and write this as 11 minus x. That works too. I like to just throw that plus there. That seems easiest. Okay. In other words, let's redraw just that little triangle. This side of the triangle, this is below 11. This is defined by this function here. This is a piece of the line y equals 1.4 plus 1.4 x minus 11. This side is a little piece of the line 1.4 minus 1.4 x minus 11. This is the part of it that's above 11. Okay? So that gives us equations for our two functions that are going to define our radii, but we want them in terms of y. So I just need to reverse these equations, right? I need to undo this, so I would subtract 1.4, divide by 1.4 here, and add 11 to give me x. And I'll do a similar thing here. I'll end up with y minus 1.4 divided by negative 1.4 plus 11 equals x. Okay, so let me remind us why we did that. The radius, let's look at the little radius, that would be this side, is the x distance from the y-axis to this point on the graph. Whatever the x value is at that point is the distance. However, we want it in terms of y. that x distance can be given in terms of y this way. Okay, so now that gives us an expression. In fact, let's just write it here. This is our little radius. This is our big radius. Okay, so let's keep going with this. So now, what do we have? We've got the volume of a disk, of any particular disk, will be pi times r squared minus little r squared. I'm just factoring that pi out from that formula there, times the height. Let me put a little I here just to remind myself I'm just talking about a particular disk. This will be pi times, so our big radius, just reading off these equations we got a moment ago, will be y minus 1.4 over negative 1.4. Oops, sorry, let's scratch that line. Pi times, this is going to get a little ugly, y minus 1.4 over negative 1.4 plus 11 squared, minus the expression for the little radius we got a moment ago, times delta y. And so when we imagine adding up all of these slabs, these disks, and then shrinking their heights to 0, we go to our integral, which will have the same form. I pulled the pi out front. I'll have y minus 1.4 over negative 1.4 plus 11 squared minus y minus 1.4 over 1.4 plus 11 squared dy. One more piece we need is what are our limits of integration. So let's come back to our picture. We're thinking in terms of y. We're going to start at the bottom of this triangle, which is when y equals 0, and we finish when we get to the top, which is y equals 1.4. So 0 to 1.4. Right? And that should give us, that's the integral, sorry, can't see that. So I just put in those limits of integration from 0 to 1.4. And so this integral is the one that should give us the volume we're looking for, right? I'm going to leave that for you guys, right? There's just, you would expand this one, you can combine like terms. What you'll get is a quadratic, so you'll get some kind of right? You'll get something of this form. Some constant times y squared plus some constant times y plus some other constant, which is an easy enough integral to do. So I'll leave that for you guys. So hopefully that helps you see how this one was going to work out. I know a lot of people struggled with putting together the absolute value, writing it as this piecewise function. We don't have an antiderivative of absolute value. We have to turn it into two lines. And then in this particular case, we also see that those two different lines are what defines our inner and outer radius. Okay,